Over the last year, GPT-3 has excited people within and outside the NLP community, specifically because of its incredible text generation abilities. Many have begun to say that GPT-3 is one of the first examples we have seen of true AI, and has consequently led many people to believe that GPT-3 could potentially be weaponized for undesirable purposes. Therefore, OpenAI, who are the creators of the GPT models, have not made GPT-3 publicly available yet. So, the purpose of this video is to get a better understanding of what GPT-3 is really all about under the hood, and how it actually is able to generate new, convincing text. Let's first see GPT-3 in action. As a human, consider the situation that you have some English homework where your teacher wants you to discuss the impact of social media. However, you are really tired and are not able to generate any strong arguments in favor or against social media. So, what you do is write the first sentence of your essay, something like, "We are all increasingly spending more time on social media, but is this really a bad thing? Perhaps not." But then, to generate the rest of the paragraph, you can use GPT-3. Taking your first sentence into account, GPT-3 produces the following paragraph. "The problem is that social media does seem to create a lot of pressure on people who sometimes can't cope and end up getting distracted, losing focus, or even committing crimes. But maybe, just maybe, it's not the worst thing in the world. If anything, social media can help people achieve better mental states by helping them communicate better and, in particular, by helping them to express their thoughts, feelings, and ideas." We can see that this is pretty decent and actually quite scary, as it's pretty much impossible to tell whether this paragraph is written by a human or AI. Let's briefly look into the history of the GPT models to begin to appreciate their evolution. The story is more interesting in reversed order, so let's start with the most recent GPT model, GPT-3. Here, on the x-axis, we have the year a given GPT model was released, and on the y-axis, we have the number of parameters in the GPT model. So, GPT-3 was released in 2020 with one astounding 175 billion parameters. The year before that, in 2019, GPT-2 only had 1.5 billion parameters, and the year before that, the first GPT model only had 117 million parameters. It is clear that there has been an exponential explosion in the number of parameters. But what do we mean by the number of parameters for the GPT models? Like many other systems, the GPT-3 model can be considered as a neural network that transforms an input into an output. In this case, the input is the starter sentence provided by a human, and the output is a continued paragraph generated by the system. The number of parameters are simply the number of learnable weights that must be tuned during training for the deep neural network. Let's dig a little deeper under the hood and see what the neural network is for GPT-3. The transformer architecture is infamous in the world of natural language processing and even has begun to have applications in other areas. The transformer architecture was proposed in 2017 in the famous "Attention is all you need" paper that sparked a series of pre-trained transformer-based language models, including BERT, Roberta, Albert, XLNet, Electra, and even the GPT models. So, the transformer architecture can be split into two main chunks: the transformer encoder and the transformer decoder. The GPT-3 model constitutes of only the transformer decoder as its main architecture. The multi-head attention mechanism that connects the encoder and decoder is removed. So now we have the final architecture of the GPT-3 model. The input comes in from the bottom and the generated text is produced from the top of the block. There are really only two main parts to this model. The first part is the multi-head self-attention mechanism, and the second part is a straightforward feed-forward neural network. If you are unfamiliar with how the attention mechanism works, check out our video on attention mechanism, or if you want to understand the transformer architecture in more detail, do take a look at our video on performers. Note, there are multiple layers of attention mechanism and the feed-forward network. The increase in width, depth, and the number of layers leads to the billions of trainable parameters defining a GPT-3 model. Okay, what we haven't discussed yet is how the GPT-3 model is actually trained to generate new text. In short, GPT-3 is trained using next word prediction by using a large amount of text available on the internet. Let's go through an example. Say we will train GPT-3 using a random sentence from Wikipedia, such as, "The Queen of the United Kingdom, Elizabeth II, is the world's oldest living monarch." The transformer decoder will train its parameters so that it can predict the next word using a bunch of words at the input. So, if the first word is a special token to indicate the start of a sentence, the model may predict the next word to be the. We can see that the prediction in this case matches the label, and hence the loss to be minimized will be 0. Now if we have two words at the input, the model may predict the next word to be planet, but the labeled word we have is queen. So the model's parameters will be adjusted in order to account for the mistake made by the model. In this way, the model can continue training its parameters so that it should be able to predict the next word given the previous words. For those of you familiar with the attention mechanism, the future words at the input are masked out so that the next word is predicted using only the past words and not any future words, and hence the attention mechanism is unidirectional. This is known as autoregressive. It is also important to note that the training process on a given input sentence is parallelized, such that the model is trained in parallel to predict each of the output words using the history of words. This is only possible because we have the labels available, as we know what the next words are meant to be for a given sentence that we have selected. This process can now be repeated using as much text as possible from the internet, so that the model has encountered as many examples as possible. In this way, the GPT-3 model has a very strong understanding of language and will be very good at next word prediction given the previous words. At generation time, the labels are obviously not available, and hence the process cannot be parallelized. So words are generated one at a time, where the predicted output word is appended to the input sentence in order to predict the next word. Well, that's a quick intro to GPT-3, and hopefully you're excited about its release as much as I am.